Hi, I'm Ali and I'm back with the second video of the blockchain series. In the first video, we saw how we can create a dApp or a distributed application that runs on the CLI and connects to the Tezos blockchain. We were able to read existing data, send operations to be included in the next block, and call entry points from a smart contract. In this video, we are going to create a dApp that runs on the browser. While some of the concepts like sending operations and awaiting confirmation are exactly the same, others, especially the ones that involve handling secrets, are fundamentally different. This is because your dApp users are unwilling to share their secrets with your dApp. That raises the need for the concept of crypto wallets. We will see why this separation is needed, how it works under the hood, and how the tools we use are abstracting away the implementation details so that you can focus on your business logic. Let's see how it works. In our previous video, while writing our CLI dApp, we needed a way to store our private key. We kept it in our source code, which is, as you know, not a good practice for production. We did not discuss a real solution because for applications that run on a desktop or a server, there are existing ways to manage our secrets, like keeping them in environment variables or using a secret manager of your runtime. But a browser dApp is published to the world. You don't want to publish your secrets to the dApp because it will be available to the entire world. And your users are unwilling to share their secrets with your dApp as well because they don't fully trust your dApp. The blockchain ecosystem has a nice solution to this problem. While your dApp creates the operation, a separate system called a wallet is responsible for signing them. A wallet is a piece of hardware or software that keeps the user's secret and can help the user sign the operations. The user is only expected to trust their wallet. Wallets are audited for quality and security. The user might have already set up their wallet before any interactions with your dApp. Now, you, as the dApp developer, will create a smart contract and a dApp. You will deploy your smart contract to the blockchain and your dApp to a server or cloud. When the user wants to interact with your dApp, they will enter the address in their browser, or they might click on a link which will take them to your dApp. The browser will contact the server or the cloud and it will respond with your dApp. Now, when the user starts interacting with your dApp, it will show the user an option to connect to a wallet. The user's wallet will ask for user's confirmation, and if the user has actually initiated this connection, it will confirm the connection. After that, a connection between your dApp and the wallet will be formed. Now, because this connection is created, whenever the user starts interacting with the dApp and it will require signing an operation, the dApp will send the operation to the wallet. The wallet will show the user information about the operation and the user can approve that operation. If that is approved, a signed operation will be returned to the dApp. And the dApp can send the operation to the blockchain, which might in turn call some entry points of your smart contract. The blockchain sends back information about the operation to the dApp, which can show the results to the user. We are going to use React to create our test dApp. And in order to create a React dApp, we are going to use the white latest create and the template react-ts, which will create a ready-made React dApp for us. I'm going to open it in my favorite editor, and after installing all the dependencies, I'll be able to run my dApp. Well, it's not a dApp yet, but the React boilerplate, and I'm going to initialize an empty Git repository, and because the void create has created a good git ignore for us, we are good to just commit the files. Then I'm going to install the dependencies from Taquito and Tezos ecosystem that are needed to create a browser-based dApp, which is Taquito library, Taquito Beacon Wallet library, and air-gapped Beacon dApp. So if you see, before installing all these dependencies, we only have two dependencies, two runtime dependencies. Now we have 3 more. And I'm going to go to the index.html file and change my dApps title. Let's change it to this. Then we are going to go to the app.tsx, and we are basically going to delete all the sample code that is being created for us. Our app is going to have the state that is needed by the other components that are hosted by our app, by our app. And one of them is the Tezos toolkit. If you remember from the CLI dApp, we do everything through the Tezos toolkit class, through an instance of the Tezos toolkit class. And we are going to have one instance of this Tezos toolkit in our entire app. When we connect our wallet, we are going to get the user's address from the wallet, and we are going to use that to determine if we have a wallet connected or not. And we are also going to keep the wallet as a state in the app. Okay, let's import the classes that we need. And now what we need to do is, if the wallet is connected, we are going to just if the wallet is not connected, we are going to create and show a ConnectWallet component. And this ConnectWallet needs basically all of these things that we have created: the Tezos toolkit, the set user address, the wallet, and set wallet. If the wallet is connected, then we are going to just show another component, which is a transfer component, and it only needs the Tezos toolkit. Let's go and create these components to see what is needed in each of these components. I'm going to create a folder named components. Oh, it should be a folder. And in there, we create our first component, which is the ConnectWallet. And our ConnectWallet is going to the input properties. Well, Copilot is very good at guessing what is needed. And so let's define this ConnectWallet props type. And okay, we need to define the types better. Tezos toolkit is, as we know from of type Tezos toolkit. Set user address is dispatch. Okay. Wallet is of type beacon wallet or undefined. And set wallet is again dispatch set state action beacon wallet or undefined. Okay. So first we need to have a function named ConnectWallet. And no, we shouldn't create a wallet here. We need to connect the wallet. So we are going to use the wallet property of the Tezos toolkit or our wallet to request permissions. And request permissions is going to show a wallet selection dialog to the user and allow the user to connect to their wallet. We just need to set some properties like the network type and the RPC URL. And then if the connection is successful, we should be able to get the user address and set it inside the as the state, so that our app is now able to switch to the transfer component. This whole process can fail, so let's put some error handling logic here. Now we need to create the wallet when this component is being created, and in order to avoid creating it each time the component is being rendered, we are going to use effect. And so we are going to create this beacon wallet instance, and yeah, basically okay, so what we need to do next is to set the set this wallet as the wallet provider of our Tezos toolkit and store it in the wallet state. Now this use effect should not depend on anything, because we only need to run it only once when the component is being mounted. And yeah, the rest is just a button that when clicked calls the ConnectWallet. We should be good to go. There's an error. Let's converted to lowercase. Now we should be able to import our component inside inside our app. And the next step would be to create the transfer component. So we are going to create another component named transfer. And this transfer component only needs the Tezos toolkit as an input, because everything else is already set in the other component. And now it's going to show some UI that allows us to set the target or recipient of this transfer and the amount. So let's create this state, which would be the recipient of this transfer and the amount to be transferred. And we need some state that shows if the process is being done or a process is happening. And let's also show the last operations hash. Good. Now the actual transfer logic is quite simple. We set the loading as true. And the operation is simply transferring the amount as mutes to the recipient. We should be awaiting for the confirmation, as you saw in the CLI dApp. No difference in here. And then we are going to set the last operation hash. If there's any error, we will log it to the console, and then whether or not there's an error, we are going to set loading as false. Now we are going to show all the inputs, and Copilot is creating really good initial things for us. I'm going to use a simpler thing to show the last operation hash than what it suggests. And yeah, should be good to go. There is still an error. Let's see. Okay, the amount should be a number. So we are going to use parseInt to convert this string to a number. And now okay, let's go back to our transfer component. There should be some there are some closing braces missing. And yes, so now if we are our React dApp is completed and we can try it here, but if we go to the console, we find that there are errors. So Taquito is made as a library that is usable on Node and in browsers. But in browsers, we need to polyfill the Node-only dependencies. And the easiest way to do that on React is to install this library, white plugin node polyfills. And once we do that, we can go to the white config file and use that plugin. We also need to import it. And it takes care of polyfilling all the node-only dependencies. And now our dApp should be the problem. Yes, and no more errors in console. So our dApp should be. Now if we click the connect button, it will show us a modal that allows the user to choose their favorite wallet. I'm going to use the Kukai wallet, and when they choose their wallet is going to show them a connection dialog. So now the user can review the dApp, and if the connection is actually initiated by the user and a dApp that the user intends to use, then they can confirm this connection. And if we go back to our dApp, we see that now that we are connected, it switched to the transfer component. So now we need an address and an amount, and I'm going to go to ghostnet.tzkitty.io and find an address and use it in here. And then we are going to send 100 mutes. Again, our dApp is going to send this operation to our wallet to be reviewed by the user. So the wallet is showing to the user that the operation they are going to sign is sending this much TES to this address. And the user can decide to confirm this operation. And if they confirm this operation, then our operation is going to be sent to the blockchain, and the hash will be shown in our dApp, where I'll be able to copy it, and yeah, we can see that tzkitty has already indexed our operation, and we can see details of this operation in tzkitty. Cool. We learned about the fundamental concepts that create the possibility of separating the concern of doing the business logic in your dApp versus signing the operations and secret management that stays in the user's wallet. While these concepts and flows were fairly complex, because we are using good abstractions from the libraries, it is absolutely easy for us to create a browser-based dApp. It's actually not more difficult from creating any other front-end application. Of course, if you're creating a real-world dApp, there would be much more details to take care of, but the fundamental concepts are pretty easy. Stay tuned for our future videos.